Greetings Math 10 students. In this video we're going to take a look at factoring. This is section 7.7 of the textbook, and I've broken this video into two parts. In part 1 we're going to do a basic overview of factoring, what that means and how to factor whole numbers, and we'll start moving into factoring polynomials, specifically what the textbook refers to as trinomials, although that's not the most accurate term. We're going to be factoring what is better known as a quadratic. So if you have no idea how to factor or what that means, this is the best place to start. In the part 2 video we'll take a look at some more complicated factoring questions having to do with negative signs, and we'll look at some of the trickier cases. But to get started, factoring is a fairly basic idea. The idea behind factoring is that you're given the answer to a multiplication problem and you need to find the question. I always think about this a little bit like that old game show Jeopardy, where the whole point of the show is they give you the answer to a question and you're supposed to answer in the form of the question. So you give them the question. So Alex Trebek, the host, might come up and say, "This historic Philadelphia college is over 150 years old," and you would buzz in and say, "What is Pierce College?" You're asking the question after he gives you the answer. So the factoring version of this would be Alex Trebek saying, "The answer to this multiplication problem is 12," and you've got to come up with the question. So what is the multiplication question that gives you 12 as an answer? I'll let you think about this for a moment. And there's a lot of possible answers, right? You might have said, oh, 12, well, that's 3 times 4 is 12. And that's absolutely correct. 3 times 4 is 12. So you just factored 12 into 3 times 4. That's not the only answer, though. If you think about it a moment, you might say, oh, well, 2 times 6 is also 12. And if you thought about it a little bit harder, you might say, oh, well, I could also say that 1 times 12 is 12. All those things equal up to 12. There are a lot of ways to factor most whole numbers. Now, we can get a little bit fancier here. You could say, oh, well, you know, a positive times a positive gives you a positive, but I could also have said negative 3 times negative 4 gives me 12, and negative times a negative is also a positive. And the same thing works for both of our other factors. You can also say, well, 3 times 4 works. What about 4 times 3? That's the same thing, though. The commutative property of multiplication, that fancy rule that says it doesn't matter what order you multiply in, basically implies that the reverse order is always going to work. So you don't have to list that as a separate pair of factors. But all of these are going to be answers to that question. And in fact, in the Hawks assignment, the Hawks question that asks you to factor a whole number, it's going to want you to list all of these. Thankfully, even though fractions would technically work for this, you're never going to have to worry about fractions. They only want positive and negative whole numbers, integers, as factors. So you don't have to say, oh, 24 times a half, even though that's true. You don't have to list that one. And in Hawks, the way that they'll want you to list these factors is in parentheses separated by a comma. So you'd write 3, comma, 4 to say that 3 times 4 is a pair of factors that multiplies up to give you 12. A lot of different ways to do this, though. But that's the basic idea behind what factoring is. You're given the answer to a multiplication problem, and you want to find the question. Well, that's all good and easy to do if you're given a whole number to factor, but what about when we're factoring polynomials? Well, the polynomials that we're going to care about are called quadratic, although the textbook uses the term trinomial. I don't 100% agree with that, but that's neither here nor there. And those are polynomials that have an x to the second power, or x squared, in them. So for this whole section 7.7 and the whole of section 7.10, all we care about are polynomials that start off with x squared, or x to the second power. How on earth do you factor those? That's going to be a little bit trickier than factoring just a plain old whole number. So how do we factor a polynomial? Well, to answer that question, let's think back to how we multiply polynomials. And if you don't remember, you can take a look at the video on section 7.4 to remind yourself. But I'll do a brief review right here. To multiply two polynomials, these are very basic polynomials. Basically what you do is I take a look at the first polynomial in this parentheses, and I'm going to distribute the first term, the x, to each term in the second parentheses. So x times x is x to the second power. That's basically the definition of x squared is x times x. You can also think you're adding the exponents of 1. 1 plus 1 is 2. And then this is really a 1x. So 1 times 4 will give me a plus 4, and then just bring down the x. And once I'm done with that, I'm going to distribute the second term. So 3 times 1x is going to be 3x. and then 3 times 4 is 12. If none of that made sense to you, go ahead and pause this and go back and watch the video for section 7.4. Part 2 specifically talks about how to multiply polynomials that have more than one term. Don't worry too much. You'll be able to factor even if you don't know how to multiply quite yet, but it's good to be familiar with this process. Now we're not quite done because we do have some like terms to combine in the middle. 4 plus 3 will actually give us a 7x in the middle, and then I'll bring down my plus 12 and my x squared. So I want to be able to factor. I want to be able to work that backwards. When someone says, hey, factor x squared plus 7x plus 12, I want to be able to reverse the process. So if you're ever on Jeopardy and they say the answer to this multiplication problem is x squared plus 7x plus 12, well, you know this specific one, but how would we work backwards to get that? Well, at the very least, you know that it's going to come from a multiplication of polynomials, so you'll probably have these parentheses here. And you know that this x squared term could really only come about from having x times x. So these are going to start with x's. These polynomials are each going to start with an x, and we see that from the previous question here. But how do you get these two pieces here? These two pieces, by the way, are typically often called your factors, the two numbers. Or I'll be referring to them as such at least. And how do you find those things? The only clue that you have is the coefficient of x, the 7, and the constant term, the number on its own, the 12 here. Well, think about where we got those things. That 12 came from multiplying 3 times 4 here, right? 3 times 4 gave us the 12. So this is really the product of our two factors. Product being a fancy math term for multiply. What about the 7? The 7 was combining like terms. So if the 12 was 3 times 4, the 7 was 3 plus 4. It's the sum. Remember, sum is just a fancy math term for what you get when you add two things. So that was 3 plus 4. So basically, to find the two factors, you can look at the product and sum and think, hey, what two numbers will multiply together to give me 12 and add up to give me 7? Well, as we saw before, there's a lot of ways to get 12. You could do 1 times 12, 2 times 6, or 3 times 4, but the only pair of numbers from that list that's going to add up to 7 is 3 and 4. So I know it has to be 3 and 4 in here. Now if all of that was a little bit fast or didn't quite make sense, don't worry, I'm going to write down a list of steps, but I wanted to sort of motivate the process and show you how to think about it so that the steps make sense. Let's take a look at a brand new example where we don't know what the answer is supposed to be up front. But for this particular one, the answer actually that you would type in, your final answer is this multiplication problem. X plus 3 times x plus 4. It doesn't matter, by the way, what order you put those in. You could have had the x plus 4 first, and that would be perfectly okay. So let's take a look at how to factor a quadratic. We'll go through step by step. The book calls these trinomials again. This method works for more than just trinomials, and in fact it doesn't work for all trinomials, so I don't quite like the book's notation there. That's the last time I'll mention that. It bugs me a little bit, but I won't mention it again. Alright, so how do we factor something like this? Well, the very first thing that you need to do is identify the important pieces here. So to factor this, I mentioned the first thing that you want to do is identify that product and that sum. When I say product, it's always going to be the constant term, the number that's not touching an x. And the sum is always going to be the term that is touching an x, the coefficient of x. And the way that I actually like to write this out is I'll write out, okay, my two things have to multiply up to 24, because that's my product, and add up to 10, because that's my sum. Literally write this down. For each time you have a factoring problem, write down what your two factors have to multiply to and add to. They're always multiplying to this constant term at the end, and they're adding up to the coefficient. And honestly, do yourself the favor of writing it down, and you'll find that you have a much easier time with this. A lot of the time students skip this step. They don't feel like they have to write things down, but the more you write, the less your brain has to spend important energy on just trying to remember stuff, and the more it can focus on the hard parts. So definitely just write this down. Even if you abbreviate and write something like M24 and A10, you'll find that you have a much easier time of these. Now that you've written this out, it's no longer an algebra problem. There's no x's here. I just have to find two numbers that multiply to give me 24 and add up to 10. It's almost like a little number puzzle that you might have gotten back in grade school. So what I'm doing here is I want to find a pair of factors, factors meaning numbers that multiply to 24, that also fits the sum, that also add up to 10. And so what I'll do is I'll just list my factors of 24 if I need to. You might come up with the right pair of numbers right off the bat. You might see what it is immediately, but if you don't, just try to think of the ways that you can break 24 down into a multiplication problem. 1 is always a good place to start. 1 times 24 is equal to 24. Those two numbers multiply up to 24. Unfortunately, 1 plus 24 is no good. That's 25, right? 1 plus 24 is 25, so that's too big. It does not add up to 10. But think, what else can you fit into a multiplication problem with 24? Does 2 go into 24? Well, if you're not sure, take out your calculator and divide 24 by 2. Or really, just study your times tables really well, because you're going to need to know them well for this particular section. And sure, 2 times 12 is 24. Again, you could have divided 24 by 2 in your calculator and gotten 12 to see that. Unfortunately, that's not going to work for us because 2 plus 12 is 14, so still a bit too big, doesn't add up to 10. What about 3? Does 3 go into 24? Now, if you don't know, try it out. It indeed does. 3 times 8 is 24. 3 plus 8. Oh, so close. We're off by 1. That's 11. Remember, our goal is 10. Let's try 4. Does 4 go into 24? Ah, it does. 4 times 6 is 24, and lo and behold, 4 plus 6 gives us the number we were looking for, 10. Beautiful. So we found our pair of numbers that works, that multiplies to give us 24 and adds up to 10. Did you have to make this whole list? Not necessarily. You might be able to see that it's 4 and 6 right off the bat by looking at 24 and just kind of thinking about it a bit. If you're really good with your times tables, it's probably going to take you a lot less time to do this. So what happens next? We're just going to write out 2 sets of parentheses, and there's always going to start with the x's, and they're going to end with those 2 factors that we found. So each of those parentheses is going to begin with an x and end with one of our 2 factors. And it does not matter what order they go in, but they're both positive, so we have to write plus signs in there. So x plus 4 and x plus 6 will be our 2 parentheses, and you will literally type it in HOX just like that. By the way, how do you know you've exhausted all possibilities? Well, I could try to divide 24 by 5, but it won't work. I'll get an ugly decimal, and if I hit 6, well, that's already on my list up here, so I've hit a repeat. So how do you know if you've hit all factors? I like to just be systematic about it, go from 1 and down until I've exhausted all my possibilities. But again, if you're really comfortable with your multiplication tables, you might not need to make a list at all. So to summarize, factoring is a process where you're given the answer to a multiplication problem, and you're supposed to come up with a question. When we're factoring quadratics, what the textbook will call trinomials, you're going to always identify your product and sum first, try to find a pair of factors that multiplies up to that product, that number at the end, and adds up to the sum, the number that's the coefficient of x, and then you always put it in the proper format in the end. In part 2 of this video, we're going to take a look at some more complicated examples, mostly complicated due to the negative signs. So negative signs in here will make things a little bit trickier, but not too bad if you're comfortable with your sign rules.